Hello everyone, good afternoon again and welcome to the class. So today we are going to have a class about load factor. So what is load factor? I'll be telling you all about it. Please listen to it very carefully because a lot of people get confused with load factor. It's a very confusing topic. It's not difficult, it is confusing because a lot of people cannot explain it. I've seen teachers, those who just simply give a formula and they just tell their students to just mug it up and run the show. But today I'm going to explain you how that formula is derived and how if the question comes in exam, उसको कैसे tackle करना है, formula भूल गए तो उसको कैसे derive करना है. I'll show you all that. It is important, so pay good attention to it because a lot of people, a lot of students have this problem. They don't know how the formula is derived. They get confused कि ये हो क्या रहा है. तो and मैंने काफी teachers instructors को भी देखा है. They don't explain it very well. They'll just say भाई ये formula है, which is not the best way to do. As you all know, anyways, my policy is that the logic has to be there. Everything that you learn, please understand the logic behind it. There is no point mugging things up. There is no point taking my class if you're going to mug up. Then the notes which I've given you, the books which I've given you, refer to them and just study by yourself. There is no point taking my class if you're not going to go through logic. So everything has to be logical. Now I'll explain it to you. So if you have any problem, just ask me. Ask me 10 times, no problem. I'll explain you the same logic again and again. But understand the logic. It is good for you because ultimately in exams you will remember what it was. So now there are few things which I wanted to start with. Before I jump onto load factor, I'll just brush a couple of things here. So I'm sure you can see my white screen. Now I'll draw a picture of an aircraft and I'll show you with what angle I'm drawing it. So with my hand, you all should be able to first of all make an aircraft with your hand. You don't need an arrow model. If you need an arrow model in the exams, it will not help you much. You will have to just try and learn to make an aircraft with your hand. Just take your hand like this, make the wings, put your fingers down. Okay, so this is the nose, these two are the wings, and this is the back side. So this is the plane. So you in the examination hall also, if you want to just say, okay, I'm climbing, I'm descending, I'm turning, so you can make a hand model and try to understand what it is. So I encourage people to make a hand model of a plane. So if this is a plane, this is the top view. I'm looking at the model. So I'll be showing you a plane. I'll draw a plane like this. So this is the top view. You can see a plane from top like that. Okay, so this is how it'll look. In my lectures, whenever I draw a plane like this, you should know that I'm talking about what angle, because that's really important. So these are the wings. Okay, so this is the top model, top view, eagle eye view, you can say. So this is the nose, this end. These are the wings. This is the elevator, or you can say this is the tail plane. Now, if I draw the same aircraft with this view, I'm like, you can look, nose is here, wings are here. How I'll draw it on the board? It will be like this. This is the center part of the aircraft. These are the wings. And this is the rudder. Here the tires will come. So this is, you can say, a front or a back view. So this is front view or a back view. If you see it from the back, behind of the aircraft, or from the front, it should look like this. So these here are the wings. This is a rudder. And this, of course, is the body, the fuselage, and the tires. And I don't need to write that. I guess you all understand that. And then there is a side view. I'll just show you how I draw a side view. This is the side view of an aircraft, which I always will draw. I'll draw it like this, and probably I'll draw the wings like this. So these parts are the wings, This is the rudder. Here I'll draw, probably in future I'll draw elevators. Okay, and this one, you know, it's this is the cockpit, this part, and this is the fuselage, this is the engine, this is the nose. I'm sure you all can make out now what I'm trying to say. Can I hear any yes,
sir? Yes, sir.
Okay, brilliant. Now that you understand what I'm trying to say, I will explain you what is load factor. Load factor is nothing but a ratio of lift to weight. That's it. It's as simple as that. Lift to weight ratio is called load factor. Okay. Now this is the simple part of it. This is the easiest part of it. But when we go in depth, we go a little deep into the subject, then you will understand why I was saying people get confused and it's difficult to understand. So just put your brains to it. So as of now, lift to weight ratio is load factor. This is a Dgca question. Dgca might ask you simply what is load factor. So lift to weight ratio is load factor. Simple. Not much rocket science to it. Now, load factor, which I will now from now on refer to as LF, load factor, is denoted by the letter N. Okay, letter N. Now there are four kind of situations which Dgca already has, and you have to they'll put answers on those four situations. The first situation is when the aircraft is flying straight and level. Straight and level. Straight and level means the aircraft is just going straight like this. It's not going up, it's not going down, it's not turning, it's not anything. It's just flying straight in a straight line like this. It is not ascending, it is not descending. It is going straight and level. So in this case, load factor will be what? So plane always exerts 1g. Okay, and lift has to counter that 1g. So if there is 1g of weight which is going down and lift is compensating that 1g, so lift is equal to weight, which means lift is equal to weight. So what happens? Load factor will be lift upon weight, which is 1 upon 1, which is equal to 1. So in a straight and level flight, load factor will be 1. Very simple. There is no rocket science to it. In a straight and level flight, the plane is not going up or down. It is just going straight. There's 1g of force going down. Lift is countering that 1g force. So if you divide lift by weight, the answer is going to be 1. So in a straight and level flight, value of n, which is load factor, equals 1. Now, second point is, this is the first point. Second point is when the aircraft is turning. When it is turning to any angle, left or right, aircraft is turning, but it's a coordinated turn. Now, what is a coordinated turn? I'll tell you. So, if this is the aircraft, I'll just okay, just a second. I'll try and share my full view. Okay, not able to do that. But anyhow, what is a in a turn? There are three types of turns. One is ascending turn. Now here aircraft is ascending and turning. See, See this view, ascending and turning. Then there is a descending turn. Aircraft is descending and turning. It is going down and turning. And then there is a coordinated turn where aircraft is maintaining the same level. It is not going down, it is not going up. It is turning, but at the same level. So this is ascending turn, descending turn, and coordinated turn. We are talking about now coordinated turns. So how load factor will be affected in a coordinated turn? This is a little, here it becomes a little tricky. So please understand this concept. I will draw a plane. I'll draw a front view or a back view, whichever you may want to call it. So I showed you the views. This is an aircraft in a turn. Okay. These are the wings. Okay. Earlier I drew an aircraft which was this, like this. So it's a straight aircraft. This one here is a straight aircraft like this. But now this one which I have, this aircraft which I have just put on the screen, this one is tilted like this. It's taking a turn. It's going that way. Okay, so this is the view of a turning aircraft. Now what happens when an aircraft is turning? 1g of force will definitely be there, obviously, because of weight. It will be obviously acting towards the ground, towards the earth. Okay. Compensating that, there has to be a lift to be generated. Okay. And because the aircraft is turning, there has to be, the lift actually splits into two. There has to be a vector involved. Lift has split in two. Lift is here and lift, this is also lift. Because lift acts perpendicular to the wings. So lift has shifted basically from here to here. So there is lift here also, and there is extra lift here to support the turn. Okay, if aircraft is going like this, you're turning the aircraft. Now if you don't add extra lift, extra throttle to it, if you don't push your column, and if you don't add power to it, it will start going down. It will start turning and going down. You don't want that. You want a coordinated turn. Coordinated where it doesn't ascend, doesn't descend. It goes like this. The moment you turn your aircraft, the lift which was straight now will go like this. And there will be a component of lift which will be straight, of course. So the lift will have actually two separate vectors. Okay. Now let me clean this diagram a bit. Yeah. So you will see that if I join these two lines, this becomes a right angle triangle, right? We call this as lift, this line, we call this as weight, the one at the bottom, and we want to find x, right? This angle here, let's call it theta. Now, in your 12th standard in physics and all, you must have read about this equation. Cos theta equals adjacent upon hypotenuse. In this case, this is adjacent, this line is adjacent, and this is the hypotenuse because this is the longest line. Okay, so we have named this hypotenuse line as x, and we have named this line as L. So according to this, if we put in the values, cos theta equals L upon x. X equals L upon cos theta. Okay, we have come to the value of x. Now let's carry on with the formula load factor. Load factor is lift upon weight, where this is the is again a lift basically. This is lift has shifted. I told you the lift shifted over there, and weight anyways can be called lift. So the formula will be L upon cos theta divided by L. In other words, it will be L upon L cos theta. L and L can cancel, and load factor then will become 1 upon cos theta. This is the formula that you have to remember. But how this formula is derived, this is how it is derived, how I've told you. You don't have to actually remember all this, but then it is better that you keep that in mind, that cos theta equals adjacent divided by hypotenuse, so that if you forget, by chance you forget this load factor is equal to 1 upon cos theta, then you can actually go back to this diagram and everything, memorize this diagram. Otherwise, this is what is mainly required by you. LF, load factor, equals 1 upon cos theta in turns, whenever we are taking a turn. So have you understood this, or have you any doubts? Anybody?
No, sir.
Yes, I have understood this. In fact, मैंने बहुत सारी classes ली हैं, मुझे ये समझ में नहीं आया था कभी भी. I always had doubts, sir.
Oh, okay, nice. You understood that?
Yes.
Okay, brilliant, very good. That's nice to hear. Rohan, you've understood this?
Yeah, sir.
Okay. So once again, just quickly, this was the aircraft. Now this is the new vector. Lift is always like this, which is equal to weight, like this. This is weight, this is lift. These both are equal. Now, but when you are turning, then there is a new vector of lift which comes in the play, this vector, and we have to calculate this. Okay, this angle you can say theta. This is a right angle, so we can obviously call this x. So cos theta will be L upon x. X can be also called L upon cos theta. And when you put this in the formula of load factor, which is lift upon weight, where lift is L upon cos theta, and weight can also be called L. So we divide it by L. L and L cancel, 1 upon cos theta is the answer. Okay, now we'll put values on this theta. This is a table now I'll give you, which you have to again memorize, because of Dgca asks you the questions based on these figures. I'll write LF here, load factor, and I'll give you different degrees here, 45, 60, and 70. Now, the question Dgca people might ask you is, imagine if the aircraft is banking at 30-degree angle, then what would be the load factor? Now you have to calculate that. How will you calculate that? With this formula. Load factor equals 1 upon cos theta, 1 upon cos 30. Okay, which will be 1 upon 0.86 something. And when you calculate it, it will come out to be 1.15. Same ways, if they ask you about 45 degrees, it will be 1.41. For 60, it will be 2. For 70, it will be 3. Okay, this table you have to memorize. They will ask you if the aircraft is banking at so and so level, then what will be the load factor. So you have to memorize this to make it easy and quick. If you want to solve it quickly, if you want to take your own time, then you can use the formula 1 upon cos 30 and keep multiplying, dividing, and everything, whatever you want. But this table, if you memorize, then it will be very, very easy for you to do the sums over there. But main thing is that the logic which I explained you, it has to be kept in mind. That logic has to be kept in mind so that you never forget how you came to this formula. Okay. Now, what it means, 2, 3, it means G, 2G, 3G, These are all G forces. Okay. 2G means that if you are taking a turn at a bank angle of 60 degrees, that means 2 times the weight of your body. If your body right now weighs say 70 kgs, so you will feel as if your body is 140 kgs now. If you are taking a 60-degree bank, at a 60-degree bank, your body will feel as if you're taking 140 kgs of weight on you. It will be very difficult for you to lift your arm, because your arm will be twice the weight of your arm right now. So that is 2G. When it becomes 3G, it means 3 times the weight you will be carrying. So G forces are these are positive G's, and they make you a bit uncomfortable because they really impose the extra weight on you. So why we calculate load factor? One of the basic reason is that each and every aircraft is designed to take certain kind of G's. They are designed in such a fashion, like fighters are designed to take up to 10 to 12 Gs. They can take 12 Gs also. But an aircraft, say Cessna 172, is designed to take 3.5 Gs. You cannot cross 3.5. In fact, you cannot come near to 3.5. You'll have to stop somewhere near 2.53 maximum. Because if you happen to cross 3.5 Gs, your aircraft will have structural damage. The stress on the aircraft will be so much that it will damage. It will cause it to crash or anything. So that is why every aircraft is designed with a specific G, and that's how they tell you that this aircraft can only take so many Gs. Then you have to calculate the load factor, that you should not be going over that G so that you don't have structural damage. Secondly, when you will be flying commercial airlines, there will be passengers sitting behind you. If you give them Gs, if they are feeling a lot of Gs, more than 1 G, if they are getting, they will be very uncomfortable. They might vomit, they might feel very uncomfortable, and headaches, nausea, all sorts of things. That is why you have to be very wary of load factor, that you don't give them a lot of G forces to experience, because that will be a very, very bad experience for the passengers. So this is why we calculate Gs. But okay, so this was the scenario when we were turning. In a turn, how Gs happen. Now, according to the calculations, you must have seen that during turns, load factor, which is denoted by N, is always greater than 1. Okay. What were they? At 30 degrees, we were having 1.15. At 45 degrees, we were having 1.41. At 60 degrees, we were having 2 Gs. At 70, we were having 3 Gs. So none of these figures are less than 1. They are all greater than 1. So in simple words, when the aircraft is turning, in a coordinated turn, when the aircraft is turning, the Gs will be more than 1. Okay. Now, also from the formula, you must have seen that formula for load factor for a turn is 1 upon cos theta. Now, in this formula, there is no mention of speed. So please don't ever come to a conclusion for your answers because of speed. If somebody says the speed is doubled, what will happen to load factor? Well, speed is not in the formula. Nothing will happen to load factor because of speed. See, every aircraft has a specific speed associated to specific bank angle. If the aircraft is banking at 30 degrees, if it's a Cessna, it's banking at 30 degrees, there is a specific speed at which it can bank at 30 degrees. The moment you slow down the speed, or the moment you go faster, the bank angle will automatically change. You cannot maintain the bank angle. So every aircraft has a different speed associated to different bank angle. A fighter jet may have a very high speed, say at a 30-degree bank angle, it might be doing somewhere around 500 knots. At the speed of 500 knots must be turning at a 30-degree bank angle. but it will be the bank angle which will determine the load factor, not the speed. Okay, so they might try to trick you. The DGCA questions, they might try to ask you if the speed is doubled or speed is halved, what will happen to load factor? Nothing will happen. Please don't be fooled. The formula is in front of you. Load factor is totally dependent on theta, cos theta. Theta means the angle, the bank angle. More you bank, more the theta, value of theta will change, and total value of load factor will change. Otherwise, no other factor, no speed factor, no other factor can change it. Fair enough? Have we got that straight? Shall I move on?
Yes, sir.
Okay. Now we have aircrafts which are ascending or descending. Okay, load factors in the aircrafts which are ascending or descending. So what will happen to load factor in the ascending case? Rohan?
Greater than 1.
Greater than 1. And load factor in descending case? This case?
In descent, less than 1.
Less than 1. Okay.
Yes, sir.
Now, this is why initially I said that this is a very important topic, and a lot of people get confused. A lot of students get confused, and a lot of people, a lot of instructors also, they can't explain their students why this is happening, why it's not. But these answers are wrong, basically. In both ascending or descending, load factor is always going to be less than 1. Both. Now, I agree, students get confused where they see, oh, the aircraft is climbing, so the lift should be more than weight. So the load factor should be different, should be more than 1, because we need more lift because of ascending, because the aircraft is ascending. And a lot of people think, oh, because it's descending, not much lift is required, so the weight should be more than lift, and which is why the load factor should be less than 1. But this is how a person, any normal human would think. Okay, this is the scenario. What Rohan said is what anybody would think like this, but that is not the case. And here is the explanation which I'm going to give you right now, why it is not the case. And please listen to this very carefully, because like I said, not many people can explain this, and they would just give you a simple answer for this and just say, they'll give you a formula and they say, okay, that's it. So I'll just quickly go through this. So there is an aircraft here and it is going upwards. So what is happening is, this is lift, this is weight. Now weight is getting actually vectored into 2 parts. Now this is getting into 2 parts. Now you can again see a right angle here. Let's call it X. So what is happening? Cos theta equals adjacent upon hypotenuse, weight upon X. So X is equal to weight upon cos theta. Now put it in the formula of load factor, lift upon weight. So lift can also be called weight. So it will become weight upon cos theta, right? Weight will cancel, cos theta will go up. So cos theta will remain. Load factor equals cos theta. That's it. Now you put any value of cos theta, 30, you put 30, it will come 0.86. So it is less than 1. So that concludes that in ascending or descending is the same thing, it's the opposite of it, but it will be vectored into 2. Weight is vectored into 2. So the formula for ascending or descending aircrafts, the load factor formula will be just simply cos theta. Whereas in a turn, when we were turning, load factor formula became 1 upon cos theta. Now in ascending or descending scenarios, load factor will be simply cos theta. So load factor will be, in other words, simply less than 1. In this case, more than 1. So according to DGCA, 4 questions which usually come, I will very quickly put it here. Here it is. In straight and level flight, I'll write here, straight and level flight, load factor equals 1. In turns, load factor is always greater than 1. In ascending or descending, climbing or descending, load factor always less than 1. And then there's the fourth one, dive, where load factor equals 0. Dive is something where aircraft is just falling. It's diving. It's diving. Well, let's say there are no engines, no power is involved. No engines are on, nothing. It's just simply going for a dive. When the aircraft is going for a dive, the load factor becomes 0. It means you will feel 0 weight. You will feel weightless. If you're not tying the seat belt in the aircraft, if you're holding a mobile in your hands, everything will start to fly all of a sudden. If you go in a dive, that is why load factor becomes 0 at the time of dive. So these 4 you have to learn them by heart. These 4 of them, and I've explained it to you how it is, the logic behind it, why it is more or less. But this is the end of it. You have to understand. They'll ask you the question simply that if the aircraft is turning, what will be the load factor? In ascending, will the load factor be greater than 1, less than 1? In a dive is a very common question Dgca usually asks. Dgca usually asks that aircraft in dive, what will be the load factor? So answer is 0, as you can see. So that was our chapter on load factor. Now we'll take a 10 minutes break and we'll be back soon. Okay, is that fine?
Okay, sir.
And then we'll take
Thank you,
any
sir.
doubts if you have any. Okay.
Okay, sir. Thank you, sir.
All right. Thank you so much, guys.
Thank you, sir.
Thank you.